Hello guys, welcome back to our next lesson on direct proportions. We talked about proportions, and the ones that we looked at actually would have been direct proportions. So let's define a direct proportion for you. This is simply a relationship, and by relationship I mean a ratio, or a proportion, when where we increase or decrease in one quantity causes the same kind of change, either the increase or the increase in another quantity. So basically what I'm saying is if one value goes up, the corresponding value would have to go up as well. Most of the time when we talk about proportions, this is what people mean, a direct proportion. So just to kind of explain that a little bit better with an example here, I've given you a problem for us to work through. So here's our problem, and you'll notice a lot of these become word problems, so it comes down to understanding what the problem's asking and how I'm going to set it up. The big thing with your proportion problems is going to be getting them set up correctly. By now you probably know how to solve them. We did that in the last one using our cross products. That's not too hard. The tricky part is making sure we set it up correctly so that we get the right answer when we do solve it. So here's our problem. Sierra makes money by creating comic books. If she makes 5 comic books, she will earn $70. How many comic books does she need to make if she wants to earn $630? So in order to solve this, what we're going to do is set up a proportion. There are other ways we could go about doing it. It would still be proportions. What we could do is we could create the unit rate and find out how much it is for each comic book and then divide. And it would be a very multi-step process. So the easiest way for us to do this is going to be to set up a proportion. So what I've showed you is the format here. What we want to do when we have direct proportions is we want to have the same items in the same spots. So if I set this up with the number of comic books over money on one side, so in the first sentence it tells me for 5 comic books she'll earn $70. We can write that as a proportion, which I've done here. 5 comic books to $70. Sorry, a ratio. It's a proportion when we have 2 that are equal. So I can set that up as a ratio. For every 5 comic books she gets $70. We know that. It gave us that information. Now, in order for us to set up the proportion, since this is a direct proportion, I need to set up my second ratio with my items in the same spot, which means I still want comic books on top and money on the bottom. If we invert those, we're going to wind up with an inverse proportion, which we'll talk about later. They're more complicated, figuring out how to set up. These ones, what you want to remember, same thing in the same spot. So I did comic books over money, so I need to do comic books over money. So the next sentence says, how many comic books does she need to make to earn $630? So it gave us the money. It didn't tell us how many comic books. So I'm going to use a variable, and I just like to use X when I don't know what it is. So I don't know how many comic books I need to earn $630, but I know that these two ratios form a proportion because these are going to be directly proportional to each other. The more comic books she sells, the more money she's going to make. An increase in one creates an increase in the other. That's a direct proportion. So what I did is I set it up here, and then we know that we can use our cross products to solve it. So if I multiply 630 times 5, I get 3,150. 70 times x is 70x, and then from there we're just solving our proportion. I'm going to undo my multiplication by dividing. When I do that, I find out the answer is 45, and then you'll notice I've labeled it. These are word problems, so we want to say what it is that we're making. Comic books. It's 45 comic books, not $45, not 45 sheep. We want to make sure we know what it is that we're talking about. So 45 comic books. We want to make sure that we're labeling everything. So we're going to take a look at a few more of those. And again, you'll notice they're word problems. So we're going to read through the problem, make sure we understand what it's asking, set up our proportions, because that's the big thing. Once we set it up, solving them is not too difficult. It's just a matter of making sure we have them set up correctly. So a mass hanging on a string causes it to stretch. If a 3 kilogram mass stretches the spring 63 centimeters, well, what I'm going to do is I'm going to write my first ratio right now because I've already seen it here. I used a 3 kilogram weight, and it stretched the string 63 centimeters. So I'm just going to pause right there and write down my first ratio because 3 kilometer mass or weight makes it stretch 63. So it's given us our first ratio. Now, pay attention because I put kilograms on top. So that means on my second one, I want to make sure that I have the kilograms on top and the centimeters on the bottom again, okay? So that we make sure we've got it set up properly. So let's keep reading. So what will the length be? So I don't know my length. that's my variable, when a 5 kilogram mass is used. So I can plug in my 5 kilograms on the top there. So I have kilograms on top, centimeters on bottom, centimeters on bottom. Now, just so you know, it wouldn't have mattered if I flip-flopped this. I could have done centimeters over kilograms as long as both sides were flip-flopped. So if I'd written it the other way, with centimeters over kilograms, that would have been fine. The only difference is kilograms would have gone on the bottom, centimeters here would have gone on the top. And then you'll notice I'd still be multiplying the same values. So it doesn't matter which one goes on top, you just have to make sure you're consistent in how you set it up. All right, I'm going to erase this one just so it doesn't confuse us. And we're going to stick with this one. Okay, now we have our proportion set up. Now all we have to do is go about solving it. And here I'm just going to flip colors. I like to do that so that it's kind of color coded. So here I've got 3 times x, which gives me a 3x. Over here on this side, I've got 5 times 63, which for the sake of time I'm going to use my handy dandy calculator. Gives me 315. All right. Now all I have to do is solve my equation. It is a multiplication one, so I'm going to solve it using division. And I find out that x is equal to 105. I was about to reach for my calculator, then I realized I could do that in my head. 105 what? Well, it was length, so 105 centimeters long is how far our string will stretch if we attach this mass. So after we're done, we want to make sure we put the proper label on it. Okay? Let's go ahead and we'll take a look at another one. A sample of paint contains 3 ounces of blue and 8 ounces of yellow. So if you have 24 ounces of blue, how much yellow should you mix to get the same color? So again, it doesn't matter which one I put on top as long as I'm consistent. So they labeled blue first. I'm going to put the blue on top, the yellow on bottom. I'm going to put the blue on top on the other side and the yellow on bottom. And I'm labeling that just to make sure I put everything into the right spot. Blues both go on top. So my original ratio tells me I have 3 ounces of blue to 8 ounces of yellow. So I'm going to fill in those ones. Then on the second part it says, if I have 24 ounces of blue, how much yellow do I need? So that's where my variable's going. I don't know how much yellow I need. That's what I'm solving for. So again, then what we're going to do is we're going to cross multiply. 3 times x and 24 times 8, which is 192. From here, I'm going to solve using division to get my x by itself. I divide one side by 3. I need to do the same to the other. And I wind up with 64, or 64 ounces of yellow paint if I have 24 ounces of blue. I don't lift that up in case you can't really see that bottom too well. So the big thing, again, like I said, is making sure we set it up properly. Once it's set up, then you can go about solving it the way that I've showed you in the other video, the previous video. And again, if you need to go back and watch that, please do. All right, one more example. If a parking lot charges $6.50 for 1 hour of parking, so I'm going to write my first ratio. They told me it was $6.50 for 1 hour. So I have dollars over hours, which means on the other side, I want to set it up the same way, so that dollars are on the top, hours are on the bottom. So if a parking lot charges $6.50 for 1 hour of parking, how long can you park for $26? So I drove into Philly, I'm parking my car, I have $26. I want to know how long I can wander the streets. So I'm going to set this up, I'm going to find out how many hours I can park for. So again, we're still solving it using our proportions with our cross product. So here I have 650x. On this side, 26 times 1 is 26. So how am I going to get x by itself? Well, now I'm going to undo my multiplication by dividing. Sorry, that was a really sloppy 5. And I'm going to use my handy dandy calculator. And I wind up with x equals 4, or in this case, 4 hours. So if I have $26, I can park there for 4 hours, just give me time to wander around and see the sites. Again, if you have questions, you can post them in the comments. You can email them to me. You can ask in class. I'll be sure to go over them. You guys have a great night, and I'll see you tomorrow.